All right, so I'm James Burke. I work at Mozilla in the labs group, and I like to make web apps. And I also like to make tools to make them easier. One of those is RequireJS. There's a link here for the slides and code, but I'm not sure how this will show up. But so I'm interested in web apps. And so why web apps? It's the largest deployed platform, but there are definitely rough edges. And, but there's some tools that help with that last mile of packaging it up, deploying the code, and getting it onto devices. PhoneGap is one of those. Mozilla is working on one, Boot to Gecko, the Firefox OS. That one's nice because it's just the booting into a web browser. So there's no complicated SDK. It's just the web with some new APIs. And I think Matt showed some of that in the first talk there. This Wavy Sandbox install, this is a repo group that I work in with one of the designers at Mozilla, Brian Clark. But it's focused on trying to make it easy to install, trigger the install APIs on the Mozilla web apps, the Chrome Web Store, and then for iOS, this is just the mechanism where you can add to home screen. It's not like the PhoneGap binary stuff, but that stuff can help get your code on a device. But I'm going to talk a little bit more about the first mile, just trying to get your code organized and put together. I work on Volo. It's like a command line package manager for getting JavaScript dependencies and project templates. It also has a simple makefile capability. But I'm going to be talking mostly about RequireJS today. And it's a module loader for AMD modules. So how many people have heard of AMD modules, asynchronous module definition stuff? So it's a way to organize your code in JavaScript. And so this link goes into a or a post I did about why I work on AMD. But this will give some background on it. This is the usual state for code in the browser. It's a bunch of script tags, and you're basically the linker. You need to work out the right order of the script tags, know their implicit dependencies. This is browser only, so if you want to do unit tests, which I think are a great idea, it would be nice to be able to run some of those unit tests without requiring a browser instance. And with this sort of model here, there's disparate automation for doing builds. Like the Ruby folks have their way of doing it. There's Django, PHP. And for web apps, and particularly ones that are like for PhoneGap or for devices, you want those to be able to work offline. You shouldn't need a server to serve those things. So those are some of those higher level problems. Once you look into some actual code, this is an example of a possible example of a view module that has this implicit dependency here on jQuery and underscore. And a lot of views have HTML that go with them that have maybe tokens in them that can be replaced with data. And you normally don't want to put that HTML directly into your JavaScript because the text escaping in JavaScript is not great. So you normally load that template in some fashion. And in the browser, that's normally async. And so you end up with having to do these more function callback APIs. Here I'm using a jQuery deferred thing. And so what that leads to is that even for your top-level APIs for your modules, like here down here for the view render, that ends up being an async API because it also needs to wait until this until this template is loaded before it can complete its work. And so I think it complicates the API. But some of the nice things with AMD, the way it tries to address some of these things, first, you get direct references to your dependencies. First, you list them out as strings, and then you get direct local references to them here in this factory function. The factory function creates the module. And then here, this define call, we're saying, hey, we're going to define a module with these dependencies, and when those dependencies have been loaded and executed, run this factory function. So, and then this special dependency ID here is actually, it's calling a loader plugin. I think this is one of the really great advantages of using an AMD-based system and using a module loader like RequireJS. The loader plugins allow you to say, hey, I'm going to create this text module, and it's just a regular AMD module. It just implements a specific API that the loader knows how to call. And so it's saying, hey, call the text plugin and ask it to load this resource ID. And so it's going to go fetch, in this example, it'll probably use an XHR call and load the text, and then you get it passed to this function. And so what this allows then is we no longer have to have those callback stuff to wait for that template to load. And so it's a little bit flatter than what this structure was. And we can even go further then. If the templates can be smarter, so okay, I'm going to actually, this TPL plugin will load the text, but then it'll also convert it to the template function automatically. And so then what you get here is you can call template function directly here with the data, and it'll return the HTML. So comparing this, we just got rid of this line, but your templating structure could be a lot more complex. I mean, the templating engine could be more complex setup code than that. But so now we're kind of reducing our amount of code that we have to write. We've got our direct dependencies, so there's no reliance on globals. You can still use globals if you want, and for some things, like Navigator or Document, that still makes sense. But for basic code stuff, this is a nice way to get the direct references. And what it also allows, we're just using a string here for jQuery, which means in the loader configuration, you can actually map that to, say, Zepto.js. And so then all the code that depends on jQuery will then just get Zepto instead. So it's sort of a nice way to say, hey, I depend on a dependency that has this particular API. And you can sort of swap out what that implementation would be. And so, so this form here, you can think, hey, if I have more than maybe 3 or 4 dependencies, this is going to be kind of awkward to manage this list of string dependencies with these local variable names. And sometimes you want to reuse code that may be originally written for Node, but doesn't have any Node-specific dependencies. But Node uses a common JS-style module format. So to make that sort of thing easier, where you want to line up the dependency name with the local variable name, there's this common JS sugar that's supported, where you can just pass the factory function now. You just pass require, and you could pass in require, exports, and module. Those are the 3 basic objects that are used in a common JS module system. But you can get those sort of references here, and then this code in here is basically just a regular common JS module. But here you can still use the loader plugin syntax that an AMD loader may understand. Sorry, after lunch. All right. So this leads to cleaner HTML. Now that we have a JavaScript API to load code, which is great because then you can actually decide to delay loading until later if you want, which is really important in mobile because, just in general, the fastest code is the code you don't have to load. So you can wait until the user clicks on a button, then to load that JavaScript, so you can save on the parsing cost until later. And even for systems like PhoneGap, or if you're using app cache, you can have the code delivered. It's local on the device. It'll work offline. You're just waiting until later to trigger the load and parse and execute. And so this thing here, RequireJS understands a data main attribute. And so what this is saying is, RequireJS, once you load the main.js file. So we have this nice API in JavaScript for declaring modules. There's very explicit dependency lists as strings. This allows some nice build tools. This is an example of a build that built that view module in with its text dependency. One of the nice things about the RequireJS optimizer is that it understands a build time API that the loader plugin can implement. So the loader plugin, in this case, this text one, it implements this write method. And so what it'll do is it'll actually inline the text as a module in this build file. So now you don't have the extra requests for loading this text file. It's all inline. We still want a stub for the text plugin in this case, but now that all of its dependencies are inlined, it can just be a stub. The reason we want this text plugin in here, these resource IDs can actually be quite complicated. If you think of something like a has.js or modernizer type loader plugin where you might have a capability check that you want to run, and then optionally load one of two files. So maybe you want to load a polyfill shim thing for, say, array extras. You could do that. So, but that sort of dependency ID can be a little bit involved, and so the loader will ask the text plugin, hey, if you implement a normalize method, I'll call you so that we can figure out the final ID for this thing. But so the nice thing about this is we have all of our code in one file now. Some of the cooler things I was just reading about, I guess WebKit supports this. I guess maybe it's the most recent version. I don't know how much, what the deploy story is for it yet, but they won't even do the JavaScript parse of a function until it's actually called. And so I think some of the other tricks you may have heard about for getting performance with combining modules, you put all of your JavaScript as strings and then eval the strings later. I'm hopeful that you won't need those hacks, and if the parser itself just decides to delay parsing until the function is called, you would just get those benefits automatically without having to do those extra tricks. But that may be more of a future thing, but it's still cool. But so the nice thing about this, we have a GitHub group set up where we talk about the AMD APIs, and we have a wiki with the APIs documented and standardized. There's a couple of different options for AMD loaders. RequireJS is one of them. There's curl is another one. Inject is one that was done by LinkedIn that it also knows how to load common JS modules directly just using XHR and eval. So that's sort of a nice mixed loader. It knows how to do AMD too. But the other nice thing, you heard Gord talk about how they adapted or require or define shim for the Cordova.js file itself. Yeah, the nice thing is that you can choose how much you need. And since we have a couple of different implementations now, you can kind of pick and choose what you kind of need. For instance, this LSJS one, it'll do like store into local storage, and then favor local storage reading first before calling to the network. But more importantly, probably for some PhoneGap apps or for mobile devices, you can get smaller shims. So Almond is my smaller shim that doesn't do the dynamic loading. It just does the basic require define API, and it knows how to do plugins. But there are other ones, like the Cordova.js one. They don't need to use plugins. They just need references to modules. And so that one can be a lot lighter. Oops. And so, how does this relate to PhoneGap? So this part here, it was going to be maybe a little bit nicer when I had the other computer, but we had to switch because my computer doesn't want to talk to the monitor. But the idea is that, so I'm interested in web apps that run across and can be deployed to a couple of different platforms. And I like PhoneGap for getting those native binaries for some of the mobile devices. But I like to just have, for me conceptually, I like to have just one www folder that has the code. And I'm really curious to see where the CLI code that Phil showed goes. I'm hoping to maybe adapt some of this approach to fit in with what they're doing there. But the idea is that, so we have these loader plugin capability with AMD. And so what we could do is say, hey, I want to require the Cordova.js that's appropriate for this platform. So I can say require env bang Cordova. And the env plugin can say, OK, well, which environment am I running in? I'm going to go load that one from the www directory. And here, I get some. Here, I'm not sure how well. I'm going to have to depend on GitHub here, because I don't know the tools on this box here. But so the idea then is that you could have your one www directory. You have your Android and iOS folder for the actual binary goo. Here I'm using a Volo file. It's just like a makefile thing, but it allows me to write, make stuff in JavaScript, which is what I like to use. But what it'll do, it'll copy over the www. So if I want to say deploy to, oops, here we'll do the iOS one. Deploy to, or run the iOS version, it'll copy the www stuff into the iOS location, and I'll do some munging here with the plist, and you can specify on the command line here. Oops, let's see how I can go backwards on this one here. Okay, that's what I get for not. The idea would be you'd be able to say, hey, OK, I want to try out the iOS version of the app, but I want to use my local web server to load the code in from my local machine instead of burning the code into the binary that gets delivered onto the iOS device. The goal behind this is then to be able to, what I've got it set up to do now is you just tap and hold in the web view for that PhoneGap app on the iOS device, and you wait for about a second, and then you'll get a prompt, to reload, and you say reload, and then it's going to just reload the code from your local server. So the goal is to avoid the cost of having to compile up all the stuff and deliver it and push it over to the device for every code change in the www area. I'm sure there'll be situations where you're going to need to redeploy it. Like if you add a plugin, you're going to have to do that sort of thing. But the idea then is, so this allows us then just to use the one code base that's in this www directory. And since we have the env plugin, oops, let's see. It allows us to, to dynamically switch. Here, we'll look how that's structured here. In the www directory, there's this JS folder. Here's the app.js. This is setting up the base URL, so it loads most of the code from the lib directory, and then does the app require the app main file, and then back app main. So the idea here, this is still a work in progress because what I found out, I couldn't actually load Cordova.js dynamically. It wants to be there as a script tag in the page as it's first run, because it needs to bind to the other side of the bridge. But I'm hopeful. I'm going to work with the PhoneGap folks here to try to make that nicer so that in here I could just do I can't sign, like a require env bang Cordova, and it'll just load in the right Cordova. And this Cordova reload is the one that specifies the tap to reload. And then the idea is then you could do a build with the RequireJS optimizer, and you just map the Cordova reload just to a stub module. So once you're ready then to deploy the app, you wouldn't have this hot loading of the app. You'd burn in all the resources into the www directory, deliver it to the user. This Cordova reload code is no longer there. And then the user would use it as they would as a normal PhoneGap app. So that's all I've got. So hopefully here you can check out some of the code. Like I said, it's still under construction because I want to work out some of those PhoneGap issues. But and then I also want to see how it works with tying into Phil's CLI stuff. But you can click here to at least look at the code, and you can find me online at the GitHub, Twitter, J.R. Burke. Thanks.